Hello guys, in this video we will talk about a list, and list is a data structure that is defined in STL library, and it is implemented as a doubly linked list. And how doubly linked list is implemented? We have a head node, and every node is attached or linked to this node only. And in doubly linked list we have the two pointer, one pointer that is point to the next node of the current node, and one is one pointer point to the previous node to current node. And similarly these nodes are connected to each other, and at last we have the node at the end which is called tail of the list. So this is how the doubly linked list is represent. So why we use the doubly linked list? What are the advantages of using a doubly linked list? Because we have the vector as well, we can use vector as well instead of list. But the advantage of the list is when we want to insert or remove an element, then we can use the list because it takes order of one time only. Because if we want to insert a new element, then if we want to add this node to at the beginning of this list, then it will take order of one time only. And if we insert an element in the vector, if we have an vector and if we want to insert an element at the beginning of the vector, then this whole element need to be shifted by one place to its right, and this will take order of n time. And similarly if we want to delete any element, let's say we want to delete this element, then only it will take order of one time only. In the case of vector, if we will delete this element, then uh, this uh, this element need to be shifted to its left by one position. So in this way, insert or remove operation take order of one space in the list. And as we can insert the element at the beginning also and at the last also, and delete as well. And for this, list provides a function as pushback pushback function to push the element at the last of the list or at the end of the list. And similarly we can push at the front. If we want to push an element or we want to insert an element at the beginning of the list, then we can use push front. And similarly we have pop back to delete the element at the last, and pop front to delete the element from front. And many functionality are also available in the list. Let's discuss the code, then we will understand it better. So how the list is defined? First of all, library of the list, header file of the list is declared. Then we can declare the list as list keyword, and what are the type of the element that we want to store in the list is, for example, we want a list of integer, then we will declare list int and the variable name that is l, and we can initialize also. Let's say we declare some numbers, so we can initialize the list by this, and we can iterate over the list also, like we can print out each element of the list. See, we can print out each and every element of the list. So if we want to find out the first element of the list, then there is a function which is called front. So if we say int f is equals to l dot front, then and if we print out f, then the 43 would be print because 43 is at the front. And similarly, we have the back function also as well. If we want to print the tail of the list, then we have back function and we can print out b. It will print 3 because 3 is present at the last. If we want to insert an element at the last, so we can use pushback function. So we can use pushback function. So let's say we want to push back 10. So 10 would be pushback and we can see uh, we can print the whole list. We see 10 is printed, and if we want to push the element or insert the element at the beginning, then we can use front push front. So l dot push front, and we want to insert, let's say 2. So 2 would be insert at the beginning of the list. Similarly, we have function pop back to pop the element from the tail. So we can use pop back function, and if we will print the list, then 10 would be pop out because 10 was present at the last. And similarly, we have pop front if we want to pop the element from the front. So 3 will be pop out, and see, let's see 3 is pop out. Let's say if we want to delete an element, for example 3. If we want to delete the element 3 from the list, then we can use the remove function. It will remove all the occurrence of that element, all the occurrence of defined or past element. So if we will remove l dot remove and we pass 3, then there are 2 3 presented, so both 3 will be removed. So our list will be 43, 42, 167. Both 3 are removed now. And we have the function, if we want to, let's insert more element. So we will use pushback function. Let's insert 10, then insert 3 again. Okay, now we have list as this. Now we want to print this list in a sorting order. Then we can sort this list also. So now the list is sorted now. So now the list will be printed in sort ascending order. So sort is a function to sort the list. Similarly, similarly we have the function to reverse sort. If we want to print the list in descending order, then we can reverse the list l dot reverse, and if we will print this, Then we will see list is printed now in descending order. Okay. And if we want to find out how many elements are in the list, then we have size function. Then we can see out L dot size. So currently 6 elements are present in the list. So 6 elements will be printed. Okay, let me define this after this. So now it would print 6 because 6 element is present in the list. If we want to insert an element at different position other than beginning, then we can insert the element by passing the iterator to that. We can pass the index and element in the insert function. We have insert function. Let's say we want to insert an element. Let's say we have an iterator. Oh, now let's decide insert L dot insert 3, and now we want to insert. So it would not work. Why it will not work? Because when a list is implemented as a doubly linked list, so it is not stored in a contiguous fashion. What does it mean by contiguous fashion? If we have, let's say, if we have the memory like this, so it may be present, a head is present at this location, and the next node or next element to the head is present here. So this pointer will be maintained like this. So that is why we cannot pass the static number as 3. So we have to pass the iterator to that location. So we will pass iterator as, and this will also not work because we can not add plus 3 because it is not the contiguous. It is not stored in a linear fashion. So let's say, so it is pointing at the beginning. So we will incrementing the pointer. Now we are passing the iterator and 45. Now 45 will be insert to the location that is pointed by iterator. Okay, and if now we will print the list, then we see 45 will be inserted now. See, 45 is inserted now. Similarly, we have the function of erase. So in erase also we can pass the iterator. For example, uh, we will pass the same iterator to erase the element. So now 45 will be removed. Let's see. Let me add and see 42 is removed. Okay. Yeah, 42 is removed now. So in this way we can erase the element as well. Yeah, these are the functions available in the STL data structure that is defined in the STL library, and it is used mostly when we do the code and when we use the list in our C++ code. So these are the functions that are mostly used, and these are very important functions that are defined over the list data structure.